Hello, everyone. Welcome. My name is Ari, and I'll be speaking with you all today about the impact of California wildfires through a systems lens. So let's go ahead and get started. Beginning with a bit of background, seen here are two photos produced by NASA. These photos are from the International Space Station, showing the effects of California wildfires from space. Both these photos are of the Camp Fire that swept through California in 2018. This fire was notorious for devastating the town of Paradise, California, where 90% of homes were destroyed. This was an extremely quick moving fire. On average, it was growing about a football field every 3 seconds. And tragically, 85 people ultimately lost their lives in this fire. However, this is only one fire in California's history, and on average, California experiences thousands of wildfires every single year. So in recent years, California has been prone to more wildfires with escalating intensity. Between the years 1984 and 2015, the number of large wildfires has doubled in the western US, and 8 of the last 10 largest wildfires in California's history has happened since the year 2000. And this is a trend that is predicted to continue. California's warm, dry climate is optimal for these devastating fires. About 85% of wildfires in the US are unfortunately also a result of human activity. And although human activity and negligence are contributing factors, the reason for the increased severity is linked to the climate crisis. Dry vegetation and wind patterns further exacerbate this issue. And California average summer temperatures have also increased pretty dramatically. They have increased about 3 degrees Fahrenheit since the year 1896. So due to the increased frequency of these hot and dry days, California is experiencing wildfires are started more easily and burn with more intensity once they have been ignited. Wildfires have also had a pretty significant impact on public health. When they occur, they emit pollutants, including carbon dioxide, particulates, and other hazardous material. Particle pollution can have both immediate and long-term health impacts, including asthma attacks, COPD, lung cancer, etc. Particulate matter, as a result of wildfire smoke, is also 10 times more harmful to children's respiratory health compared to other air pollutants. So with that, I want to introduce my research questions. The first is, along with the physical impacts of wildfires in recent decades, what are the socio-ecological impacts that influence wildfire risk? And second, how might the interdependencies between humans and environments change as our climate changes and natural resources continue to become more and more scarce? Okay, included here is a causal loop diagram of the effects that wildfires have and their influencers. The variables in the diagram include wildfires, humans, public health, climate change, extreme weather, forest fuel, ground cover, fire suppression, soil degradation, forest biodiversity, and prescribed or cultural burns. The systems model displays how outside factors influence wildfires and what impacts they have on the surrounding environment. In the case of wildfires, the triple bottom line is affected. Public health, as we saw earlier, affects people who are ultimately also responsible for almost 85% of forest fires. These fires result in a loss of natural resources, agriculture, infrastructure, which all also have a massive economic impact. On average, the US spends $2 billion per year on wildfire response, and that's without factoring in impacts to recreational lands or any kind of local economic impact. So the current issues faced include the combination of decades of fire suppression and forest fuel buildup coupled with extreme weather. Practices of fire suppression have included not allowing areas to burn, which has caused buildup of leaves, branches, debris, which is highly flammable forest fuel. And this fuel can accumulate on forest floors, while smaller trees can carry flames up to the crowns of taller trees, creating a more severe and, again, devastating fire. These variables make conditions ideal for fires to ignite, and the relationships between these variables are pretty problematic because they continue to feed and reinforce the wildfire variable, which results in further pollution of the environment and which ultimately reinforces climate change. So as demonstrated in the systems model, there were various intervention strategies we could look at implementing. To start, some of these interventions may include stopping emitting greenhouse gas emissions. Although the release of greenhouse gas emissions are a cause of climate change, and although we could implement this, it would have a pretty delayed response, and we wouldn't see effects for several more years. And these fires are something that are devastating our communities and our environment now. So although an option, maybe not the best response. As we saw, humans are also a primary source of starting wildfires. And although good in theory, it would be pretty challenging to control and monitor stopping humans from starting wildfires. And as examined earlier, a lot of the wildfires that are started aren't intentional. So it would be pretty hard to monitor and track. Additionally, the reason behind people starting wildfires is due to increased forest buildup in dry, hot climates that make it particularly easy for fuel to ignite. Therefore, this intervention would not necessarily be getting to the root of the issue. So something to consider. Fire suppression is a tactic that's been utilized by the federal government for a number of years. This has included avoidance of fire altogether, which has been proven unsuccessful. Research has demonstrated, although the number of fires that have been reduced on federal lands within the past 30 years, the total acreage affected by fires has increased pretty substantially. The combination of fewer fires and more acres burned demonstrates that wildfires on federal lands are typically more challenging to control and burn with more intensity than more frequented fires on non-federal land. Prescribed burning is another method that can be utilized as means of reducing dry brush and tinder buildup on forest floors, as we examined earlier. This example of a low intensity burn has pretty benign effects on multiple variables, including ecosystem resilience, water quality, community smoke exposure, and response to post-fire hazards. And lastly, the building of fire resilient communities, which kind of shifts that focus on how we can adapt to this changing world. The intervention strategy that I've identified for this issue includes a bit of a layered approach. This approach consists of a combination of prescribed burns as well as building of fire resilient communities. Resilient and adaptive communities will have more fire resistant structures, including those with Class A roofs, metal screen covers over e-fence, under decks, etc. New infrastructure will also not be built in communities without adequate defensible space, so a clearing around buildings, especially those that are in areas of high fire risk. Rather, additional safeguards will be put into place for pre-existing structures. And in order to break down additional socioeconomic barriers, relocation stipends need to be provided to those who do not have the financial means to relocate out of fire-prone areas. Financial assistance would also be provided to individuals who rent a residence or cannot otherwise afford the risk mitigation strategies associated with clearing brush or regularly trimming trees on property. Funding for these efforts would be supported by the natural resources produced by forest thinning. And this maintenance work is essential in order to mitigate the risk of extreme wildfires by reducing the kindling and tinder and availability of that fuel for fires to burn more intensely. So this approach has potential to change the relationship between humans and their reliance on their natural resources. If fire intensity continues to be a substantial threat because we do not put the proper risk mitigation strategies into place, we will see a loss of forest biodiversity. It will also become increasingly difficult to find nutrient-rich soil that has not been negatively impacted by the extreme heat of wildfires. Soil degradation will make it challenging to produce crops and will also result in a loss of income for farmers. This also, again, ties back into the socioeconomic status of the Hispanic population in particular. More than half hired farm workers are Hispanic, compared to only about 1/5 of the national workforce. This population will continue to be severely impacted as climate change continues to alter our environment. So it's increasingly important that we're centering these voices of vulnerable populations as well as Indigenous folks as we continue to adapt and find solutions for our changing environment. Thank you so much for your time. Here are my sources for the presentation. Thank you.